I often get asked, what is beyond the edge of the universe? The first thing to say is that that isn't a very well posed question, given that the universe is defined as all there is. But the person who allowed us to think about this question was Albert Einstein. In 1915, at the height of the First World War in Berlin, he presented his revolutionary new theory of gravity, which supplanted Newton's. And a year later, in 1916, he applied this theory to the biggest gravitating mass he could think of, the universe. And what the theory said was that the universe could not be still. It had to be either expanding or contracting. Actually, Einstein missed this and thought the universe was static. But in 1929, Edwin Hubble, the American astronomer, discovered that indeed the universe was expanding. Its constituent parts, its galaxies like Milky Way, flying apart from each other as if in the aftermath of a Titanic explosion, which we now call the Big Bang. But the point is that the theory only tells us that everything in the universe is steadily moving apart. So in our universe, it's not exactly the galaxies, it's the clusters of galaxies, and the distance between them grows with time. That's all the theory tells you. Now, it could be that the universe is infinite in extent, and still everything in it moves apart in this infinite universe, so it wouldn't have an edge. Or it could be that the universe curves back on itself, like the 3D equivalent of the surface of a football. Now, in some sense, the universe does have an edge, and that is because the universe was born. It hasn't existed forever, but was born in a titanic explosion about 14 billion years ago. So, incredibly, there was a day without a yesterday. But what this means is that we can only see the objects in the universe whose light has had time to get here in 14 billion years. Stuff or galaxies whose light would take 15 billion years to get here, well, its light hasn't arrived yet. It's still on its way. So, because of this, we see what we call the observable universe, and that is all the galaxies whose light has had time to get here since the Big Bang. And that's about 2 trillion galaxies. But beyond this are the galaxies whose light has not got here. So we can imagine that our observable universe, that's what we call it, our observable universe with its 2 trillion galaxies, is like a sphere surrounded by a horizon. We call it the light horizon, but it's pretty much like the light horizon at the sea. We know there's more ocean beyond the horizon. We know there's more of the universe beyond the cosmic horizon. And it could be there's an infinite amount more of the universe beyond the horizon. If that's the case, then imagine our spherical observable universe within this vast infinite universe with its 2 trillion galaxies. Beyond it are other spheres that contain 2 trillion galaxies exactly the same. However, they would contain different galaxies and different stars. So the stars and galaxies we see in today's universe were seeded by tiny fluctuations in the density of the Big Bang, of the material of the Big Bang. They were amplified, magnified by gravity in the 14 billion years since the Big Bang to make the galaxies that we see around us. And in another region of the same size as our observable universe, the initial fluctuations, the initial density enhancements that were the seeds of galaxies would have been different. So in these other regions, we would see different stars and different galaxies, in other words, different histories played out. But this brings us to something quite uncomfortable because it turns out that the standard theory of cosmology includes a period of ultra-fast expansion in the first split second of the universe's existence in the Big Bang. It's called inflation, and it's been likened to the explosion of a nuclear bomb compared to the explosion of a stick of dynamite, which is can be compared with the more sedate expansion than we see around us today, the Big Bang expansion. And because this expansion in the first split second was so enormous, the bit of the universe that we see today, our observable universe, could have come from an incredibly tiny, tiny portion of space, of the vacuum. And in fact, it could have been so small that it contained virtually nothing. Now, we know from physics that the quantum theory is our best theory of the atomic world, the microscopic world. And basically, it tells us that everything is grainy, that everything comes in, matter comes in little tiny indivisible chunks. Um, Energy comes in indivisible chunks. Everything comes in these tiny chunks, which are known as quanta. And we have reason to believe that space itself comes in these indivisible chunks. So at the beginning of inflation, the universe could, you can imagine it as just like a chessboard with maybe only 1,000 squares on it, 1,000 chunks of space. And each of those chunks of space could have either energy on it or no energy. But that would lead to only a finite number of universes because there's only a finite number of squares on this chessboard in the early universe. So that would lead to a finite number of histories for each of these other regions which are comparable to our observable universe. So if there was an infinite number of them and there are only a finite number of histories, then it means that every possible history happens an infinite number of times. So there are an infinite number of places in the universe where you're listening to me talking now, or a copy of you is listening to me now, and where I am actually talking. So this is probably deeply, deeply uncomfortable to you. It's deeply uncomfortable to me. So it's probably telling us that there's something wrong with our fundamental theory of physics, which is quantum theory, or our fundamental theory of the universe. That's what we call the standard model of cosmology. My bet is there's something wrong with the standard model of cosmology, and the reason for that is that about 95% of the stuff in the universe is invisible. It's informed that we really don't know anything about, what we call dark matter and dark energy. So there's an awful lot missing from the standard model of cosmology. So that's my bet for what's wrong.